3.5 is proving lines are parallel. And if two lines in a plane are cut by a transversal and certain conditions are met, then the lines must be parallel. And what are the conditions that are met? Well, if any of these conditions are met, then we could say that the lines are parallel. So here, the first one is corresponding angles are congruent. Second one is alternate exterior angles are congruent. Consecutive interior angles are supplementary. And then alternate interior angles are congruent. Or two lines are perpendicular to the same line. Yeah, two lines are perpendicular to the same line. Okay, so if any of these are met, any of these conditions are met, then we could say that the lines are parallel. And in the last chapter, we used the theorem that if two lines are parallel, then we could say all of these facts. Now in this chapter, we're saying if we have any of these facts, we can say that the lines are parallel, right? So it's like the reverse of the previous chapter. Let's look at number 1. It's if angle 1 is equal to angle 2, then determine which lines, if any, are parallel and state the postulate or theorem that you used. Well, first thing you want to do is identify, here's our two angles, identify the transversal that's creating the two angles. And what is the transversal? Well, it's the line that is a side of both angles. And so you can see that line M is a side of angle 2. And it's also a side of angle 1, right? No other line here can say that it's the side of both angles. Only line M can say it's the side of both angles. So M is the transversal, which means the two lines that we're considering to see if they're parallel would be R and S, right? And so what is angle 1 and angle 2? They are corresponding angles. Right? And we're saying that corresponding angles are congruent, they're equal to each other. So we can say corresponding angles are congruent. And because we can say that corresponding angles are congruent, we can say that line R and line S are parallel lines. So we're going to say line R is parallel to line S, like so. And that's our answer. Alright, so here we have example 2, and we're given that M and N are parallel. So here's N, here's M, they're both parallel. And now we want to find angle ABC. So we want to find this angle for which we have an expression. Right? So how can we find the measure of ABC? How can we do it? Well, we will need to come up with an equation to solve for x. And so what we know here is that if the lines are parallel, then the alternate interior angles are congruent. So these two angles are alternate interior angles, right? So they're congruent. So because they're congruent, we can set them equal to each other like so. 6x minus 20. We can now solve for x. So we're going to subtract 3x from both sides and add 20 to both sides. So it's going to be 30 is equal to 3x. We divide both sides by 3 and we get x is equal to 10. Alright, but we're not asked to find the value of x, we're asked to find the value of the measure of angle ABC. So we need to plug that x value back into this expression. So it's measure angle ABC is equal to 6x minus 20, like so. And then we're going to plug in the 10 for the x, right? So we get 6 times 10 minus 20, like so. Right. So if I work out the math, I'll get it's equal to 60 minus 20, which is equal to 40. So that's the measure of angle ABC. Right. So we're going to use these rules, which state that if any of these conditions are met, then the two lines that are cut by the transversal are parallel to solve these problems down here. And we also might be asked to find the measure of angles, right? And we would do that by creating an equation using these conditions here, and then solving for x, and then substituting back in to find the measure of the angle. So in the next video, I'll show you the answers to these problems down here, and